Hello again. I'm coming back with another example, another set. This one is a subset of the space, R2, and pretty much it is, a straight line, right? So S is a set of all pairs XY, you know, element of R2, right? Such that x plus 3y equal 9. So the question is S a vector subspace of R2? If yes, we have to prove the three axioms. If no, then we give a precise argument of why it is not, right? So here, we feel like, this one is not a vector subspace. Now, we can give, many, many examples. For instance, here, one of the examples of the reasons it's not a vector subspace is, we ask this question, is 0, 0, which is a null vector, right, of R2, is 0, 0 an element of S, right? You see? Of course not, because 0 plus 3 times 0 is not 9. So 0, 0 is not an element of S. And we must pretty much be done, you know. So S cannot be, S is not a vector subspace, okay, of R2. See, that's the shortest argument, okay? The other arguments, right, if you want to argue with closure under addition. If you want to argue with closure under addition, again, we pick just an example. We don't have to prove in general, right? We just pick an example. For instance, the stuff is x plus 3y. If x1, I mean, let's just do it in general. It's more eloquent, right? x1 plus 3y1, so we have x1, y1 is an element of S, which means x1 plus 3y1 equal to 9. x2, y2, another element of S, which means x2 plus 3y2 is also equal to 9. Let's add them up. This is u1, this is u2, right? So let's add them up. u1 plus u2 will be x1 plus x2, comma, y1 plus y2. Now let's see if this one is an element of S or not, right? So, which means we're gonna plug in that in the equation of S, right? Which means x1 plus x2 plus 3 times y1 plus y2. We want to know if this is equal to 9 or not, right? That's a test. All right, so we have, now we arrange this one. This one is x1 plus 3y1. And the other one is x2 plus 3y2. But because each one of them is an element of S, this means the first one is 9, the second one is 9, so it's giving me 18. So this is not 9, right? So therefore, S is not closed under addition. Right? Same way, we can choose to prove, to disprove that it is not a vector space, right? We can choose to show it, argue with a multiplication by a scalar. You can choose that. You can choose that way. On the test, you don't have to write all the three arguments. Just one is enough, right? Just one is enough. So let's say u equal to x, y is an element of S, which means x plus 3y is equal to 9. And c is a real number. So cu will be cx, comma, cy. So is it an element of S or not, right? Again, we test that on the equation. So it's going to be Cx plus 3Cy. We wonder if this is equal to 9 or not, right? So it's going to be C times X plus 3Y, right? But this one is equal to 9. So we get, this is 9C, you see? 9C is not equal to 9 for any C, for any C, which is different from 1, right? And that's enough. Again, you could have chosen one example, but I just show you because this is, for can benefit you. I just show you in this case, we can show it, disprove even it is not a vector subspace in general, just saying this is not closed under addition. But if you just provided one particular case, one example, it would be enough. Okay. All right. So this is an example of, again, as you can see, this is not calculation heavy. This whole, vector space is not to be meant heavy in calculations from what you're doing, but you have to be clear. You have to present your argument clearly. You have to spell out what you want to say. It's not like, although you don't have calculations, but I might argue it's a little bit harder in a sense you have to present your argument very clearly. Okay, so here S is not closed under multiplication by scalar. All right. Thank you very much, everybody.